Now, recalling that we are considering under Newton's law of motion the actions of forces that are occurring, the internal forces, the external forces, and a situation whereby there is no external force present, we consider them as well, take into account. So if there is no external force that is occurring, then the formula for our computation of forces is reduced to, because no external force is being exerted on the fluid flow or the flow of the fluid that is under consideration. Therefore, the value of external flow is substituted 0. The only contribution that is coming is from the internal flow that are occurring. And from internal flow, as you know, on the right hand side we have the forces on the control volume, that is rate of change of the momentum on the control volume, and then this beta terms with correction factor at inlet and outlet, both of them as they should be. In the absence of external forces, the rate of change of momentum is equal to the difference between the rates of incoming and outgoing momentum flow rates. So very simple arithmetic, and which is calculated by these numbers, these values that we have discussed now so many times. And even if some thrust is available, we can take some example in which some thrust is provided to the fluid flow, for example to spacecrafts or even the flight of the plane or throwing of a missile and so on. So in that case, the equation can be adjusted as written. F, the thrust force, is equal to the given values. The remaining values remain the same. Remember, basically Newton's laws are playing dominant role. F is equal to ma. And the thrust needed to, for example, lift the space shuttle is generated by the rocket engines as a result of the momentum change of the fuel that is accelerated from about 0 to an exit speed of 2000 meters per second after combustion. So when a spacecraft is thrown from ground, from Earth into the space, then we need this much speed to be provided to the vehicle so that it can get out of the gravity, it can the effect of gravity and go into space. And providing this force is the important thing. We call that, this is known as thrust, and this thrust is provided by combustion of the gases that are fired in the beginning at 0 second, and then it moves with a very large speed. And the speed is, you can imagine, 2000 meters per second, 2 kilometers in 1 second. Very, very high speed. So a flow, as you can see, is occurring at that level when so much thrust is provided. And the fluid flow field can be seen when the gases are burned. You can see how it look like and what is the behavior of the flow. And the thrust is provided because the forces act in an equal direction. They burn this side, the gases, they flow downwards, but the reaction is provided in the negative direction in which they are moving. So it moves upwards and go out into the space if the required thrust is provided.